Hello everyone. Today we are going to talk about the hypertext transfer protocol. So, according to the RFC, HTTP or the hypertext transfer protocol is a stateless application level protocol. Stateless application level protocol for distributed collaborative hypertext information systems. Two words in bold, stateless. Another word in bold, application level protocol. We are going to demystify this. Why application level? The SI model has 7 layers. From the first layer, from the bottom, the layer 1, the physical layer, all the way up to the 7th layer, the application layer. The application layer is where HTTP functions. What is the application layer? Application layer is the human-computer interaction layer. What that means is that the application layer is the layer closest to the users, and HTTP is very close to you. It sends your request, it receives the response, and it displays anything. The response that comes back to you. So that brings us to this diagram where, as a user, we said that the layer 7 is the human. It is the closest to the users. So you are the client. You are closest to the client. The client is like a browser. So you send a request to the server. You requesting to load your school's website, and the server responds telling you, "I have that." It is. That's the response. There are two parties in an HTTP connection, the client and the server. You send a request to the client, you get a response from the server. What about this other word, stateless? What does it mean? What stateless means is that each request is executed independently without any knowledge of requests that were executed before it. And once the transaction ends, then the connection is also lost. Here's a diagram to explain this. You decide to load your school website at 17:59 hours. The server responds to you at 18:00 hours. Then it forgets about you. It doesn't recognize you anymore. You decide to load the website again at 18:09 hours. It responds at 18:10 hours. It doesn't recognize you anymore. Every subsequent request, every subsequent response, it doesn't even recognize that it was coming from you. It's all forgotten. We just explained being a layer 7 protocol. Now, you may ask yourself, what other protocols run on this layer 7? We have the SMTP, the Simple Mail Transfer Protocol. This is responsible for sending emails. We have the DHCP, the Dynamic Host Configuration Protocol. This assigns IP addresses automatically. You don't have to manually configure your IP address. We have the DNS, the Domain Name System, which resolves IP addresses to domain names. And we have the Secure Shell that is responsible for remote connections. Now, a story is told about identification of a process. Now, we have something called a port. So a port is a 16-bit number that identifies a process. So what that means is that we have 2 power 16 ports, which is a total of 65,536 ports. Now, among all these ports, the first 1024 ports are set aside for the operating system. And mind you, HTTP was able to grab the 80th port. So that is the default port for HTTP. However, that does not mean that if someone tries to listen on HTTP on another port, it won't work. Nope, it will work. Only that the default port is 80, but you can listen for HTTP traffic on any port that you want to. Fast forward, we're going to look at the history of HTTP. Where did the story start and how is it so far? So HTTP dates back to 1989 when Tim Berners-Lee was working at Sun. So he wanted to build a hypertext system which he called mesh. And believe it or not, this is now what we're calling the WWW. So what did Tim Berners-Lee need for him to be able to have a hypertext system? So first of all, he needed a way to format his text, and that brought about the HTML. He also needed a simple protocol to exchange these documents. That is where a protocol comes in. Yet to build and design the HTTP protocol, the HTTP. He also needed a client to display and edit these documents. Something where you can edit these documents so that you can build the hypertext system. And this brought about the first web browser. It was called the World Wide Web. Also, for this to happen, you remember, for where there's a client, there's a server. So the first server was born, the HTTPD, the early versions. Now the Apache of today, the Nginx of today, they were born back then, thanks to Tim Berners-Lee. Now, after all this work, it was completed by 1990, and this version was later dubbed HTTP 0.9. That was the first version. And HTTP 0.9 was a very interesting protocol. It was a one-line protocol. It didn't have a lot, just a one-line protocol, one-liners. So what it did was that there was only one HTTP method back then, the GET, the most basic GET. So it was only one, GET, and then it was followed by the path of the resource. Remember, Tim Berners-Lee was trying to build a hypertext system. So he only needed to load these pages. The rest wasn't of his concern. So there were no headers, there was no status or error codes, there was nothing. If there was an error, a specific HTML file was generated and included the error description. So after a while, people back then thought that it was good for them to extend the protocol, make it better. You also want to be better as a person, so they wanted to make the protocol better. So this led to a development of HTTP 1.0. Now in this protocol, versioning info is sent with each request. So it's like you're sending a request and then you're telling it, you know what, I'm version 1.0. Also, there were new changes. A status code was sent at the beginning of the response. The 200, everything okay? So now what that meant is that clients could now recognize success or failure, because if you're getting a 200, that's obviously a success. If you're getting a 400 or a 500, that's a failure, depending on what side it's coming from, client and server respectively. Now, HTTP headers were introduced for both requests and responses. That was life before without HTTP headers. You could only work on HTML documents, but now you have HTTP headers. Why don't you set the content type to application.json? Brings us to the next point. Documents other than plain HTML could be transmitted. Interesting, right? Fast forward, use a sample request. You can see the HTTP method get, the path to the resource, mypage.html, HTTP 1.0, the version. Remember, we said that the version was sent with each request. Another header, very common, the user agent. You're telling us which browser this request is originating from. Now, the sample response included a status code. As you can see below here, there's 200. Okay. And several other headers, including the content type, text.html, and the body. Now, as this was happening, as the development was taking place, a new protocol came up, HTTP 1.1. HTTP 1.0 was developed between 1991 to 1995. Now, HTTP 1.1 was launched in 1997, with the aim, of course, being to improve on HTTP 1.0. And what changes did this bring? Let's see whether it was an improvement. I believe so. So now, in HTTP 1.1, a connection could be reused. In HTTP 1.0, that was not possible. Using a connection, that was unheard of. So now, on to the next feature. Chunked responses are supported. So in chunked responses, it is like breaking down a response you can see it's a response, breaking down responses into chunks, small parts, small parts, and sending them back to the client as parts, as chunks. You may ask, how did it know that we were reaching the end? So every chunk was preceded by the size, by its size. So let's say 40 bytes, 40 bytes, 40 bytes. The moment you experience a 0 bytes, then you're sure the response is complete, because now it's a 0 size before, meaning all parts, all chunks before were full parts, or the last chunk was a partial part. So meaning you are listening until you encounter a 0 size chunk. Now pipelining was added also. So in pipelining, you could be able to send a request, and before even you get the response, you could also send another request. That was what pipelining was. It was introduced in HTTP 1.1. They were also able to add cache control mechanisms, so that you can be able to cache on pages. You don't have to request a page, get it fully, yet you can cache it. So, another feature that they added was content negotiation. Now, content negotiation involved the following. You want a resource from the server, but first of all, before you even get it, you sign a contract. You agree on, I want this resource in Brazilian language, I want this resource in English language, and all forms of negotiation that could happen. This is because of some of the HTTP headers that are believed to be negotiation headers, such as the content language and other headers. We'll be looking at them in future lessons. Now, there was this ability that came up to host different domains from the same IP address. As you'll see in this request below, we have a host here called developer.mozilla.org. So what that means is the same IP address could have several hosts. Interesting. Now, fast forward. This is a sample HTTP 1.1 request and its subsequent response. Now, things have become more complex. We have more visual media, increased volume and size of scripts, and that means that there's more complexity and overhead for HTTP 1.1. Now, due to this, Google created an experimental protocol, SPDY, which acted as a foundation for HTTP 2. So later, HTTP 2 was launched as a result of the SPDY protocol by Google. And some of the key features included compressed headers. So every time we send the same headers, sometimes they don't even change across requests, and headers account for a very big size of our messages in HTTP. So an idea was to compress them so that we reduce the size, we save on network resources. So that was the first feature. The second feature is what they call server push. Now in server push, a client and a server. Now a server pushes some message to the client cache. Let's give it an example. You're requesting for a website. This website has 3 files: index.html, index.css, index.js. Now the moment you request for index.html as a client, a server that is configured, an HTTP 2.0 server, could do this. You've requested for index.html. I know this trend, I know this pattern. Whoever needs index.html also needs index.js and index.css. So do you know what I'm going to do to you? I am going to push these 2 files to you. You have not requested them from me, but I'm going to push them to you for the goodwill. I'm a good servant, so I'll give you index.js and I'll give you index.css. The same server responds with index.html. And while the browser is passing this document, index.js and index.css are there waiting. Very interesting. It means that you're saving time. And that is server push. Very interesting. Now, also, HTTP 2.0 is a multiplexed protocol. What that means is you can have parallel requests over the same connection. So it is more welcoming, and you can send as much traffic as you want on the same connection, and you'll still be served. Now, finally, HTTP 2.0 is a binary protocol, unlike the other versions which were textual protocols. So a binary protocol transfers things in frames. The transport is in frames, binary data. So unlike in the textual protocols where you could edit or form or change the contents of the of the message, in HTTP 2.0 that is not possible because these are frames that you're sending. They're in binary format. So that means more security for you. Yeah, so that has been that has been a close look at all the generations from HTTP 0.9 all the way to 2.0. Yeah, and that's it. In future lessons, we'll be looking at more details into some of these concepts that we've talked about in this video. Thank you.